Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. So in this video we are going to discuss the question transform to sum tree. What does the question say? The question is actually very simple. You have been given a tree root as usual, and you have to transform this tree. You have to transform this tree, and that too in place. That is, you cannot construct a new tree. You cannot construct a new tree. Now you can see that 10 is converted to 20, minus 2 is converted to 4, 6 is converted to 12, 8 to 0, minus 4 to 0, and rest of the 2 are also 0. How did we get these values 24, 12, and 4 zeros? How did we get these values? So the values are actually the sum. Values are actually sum of values in left and right subtrees, and please make sure to see subtrees again and again. I'm saying about subtrees, not the children. The right and left subtrees. That is for 10, the values that are contributing, that is for this node, the values that are contributing are minus 2, 6, 8, minus 4, 7, 5, and if you sum this up, you will get 20 as your value. Similarly, for minus 2, the sums are 8 comma minus 4, and when you sum them, you will get 4 as your value. 6, 7, and 5, sum them, 12 as your value. Now for 8 and minus 4, you can see that their children are null. The null nodes have to be considered as 0. The null nodes have to be considered as 0. So 0 plus 0 gives me 0. 0 plus 0 gives me 0. Similarly 0 here and 0 here. So now you understand that how we are getting 24, 12, etc. in the answer tree. So now how are we going to solve it? The main problem is how are we going to solve it? Okay, so we are starting from the mass coder channel. So first approach we will see is the heading of the problem, which is binary tree. So whenever you encounter this BT, you say I will drill them with traversal. I have learned about some traversals, I will use them. Now it is my job to see that which traversal will I use and how will I modify it to get my correct answer. Okay, so I have got 10 minus 2, 6, 8 minus 4, 7, 5, right? Can I say that 10 needs to be replaced by the value this and this, that is 10 has to visit the left subtree. I am saying the root has to visit the left subtree and then the right subtree and then the right subtree and then the right subtree, or the order can change, it can be right and left, right, and then fill the value like how am able to determine it, how am I able to determine that? So I know that 10 has to be replaced by the left and the right subtree, and that cannot be done in any other way if I do not know what is actually contained here and here. If I do not know what is actually contained in these two circles, I cannot fill the value up here. So I will have to traverse, right? I will have to go towards left first, then towards right, then only I will have a particular value to fill here, right? So the traversal is actually taking up the shape of left followed by right followed by current. So I have seen this traversal. Who will tell me? It is post order traversal. It is post order traversal. The left right route, the famous traversal. How do we calculate post order traversal? Just a recap. We just do something like this, and then just draw the boundary, and intersection means we are going on the correct order of the post order. For this particular tree, the post order is 8, 4, minus 2, and then 7, 5, 6, 10. Okay. Now, how will I use post order? How will I use post order? So I simply said left, right, current, left, right, current. But if I just see that, if I just try to do something like that, so I have 10 here, minus 2 here, 6 here, 8 here, 4 here, 7 here, 5 here. If I see left right root subtree, I also want the values of 8 and 4. I also want the values of 8 and 4. So what can I do? What can I do? So if my call is for 10, I will go to 2 because the left has to be explored first. So if the left has to be explored first, I want to minus 2. From minus 2, I will go to 8. Now 8 will see that right is left, both of them are null. So 8 will actually convert to 0, no problem. 4, it will go to 4, 4 will actually convert to 0, no problem. Now you can see that minus 2 is actually getting, when the recursion call will come to minus 2, you will see that the new nodes I had as children are actually converted to 0, 0. Initially there was 8 and 4, which would have given me the sum of 12, but now it is only 0 0. Now it is only 0 0. So my approach should be that first I change the sum. So I applied that approach. I am implementing the changes: 10 here, minus 2 here, and it was 6 here, 8 here, minus 4 here, 7 here, 5 here, right? Okay. First thing I have to do, 10. 10 will go towards minus 2. 10 will change the value first, right? So minus 2 plus 6 will give me 4. Moving towards minus 2. Minus 2 will also change value. 8 minus 4 is 4. Going towards 8. 8 will go to 0. Minus 4 will convert to 0. Moving towards 6. 6 will convert to 7 plus 5. That is 12. 7 will convert to 0. 5 will convert to 0. Moving towards 4 now. You will see that I change the value of 10. I change the value of 10, which is equals to 4. But my answer something shows different. Answer was 20. Why did it happen? The reason is that you converted 10 to minus 2 and 6, minus 2 plus 6. But in the case of 10, you choose these two values, but 8 minus 4, 7, 5 are still missing. You have not summed them up in the 10 node. So how will you do it? So now you can see that the new values in the children are 8 minus 4, 7, 5. That is the answer to me. That is, after that you will just say 4 plus 4 plus 12. That is 4 plus 4 plus 12, which is equals to 20, and that is my tree I wanted. The algorithm is in your hands. What will you do? You will first convert the sum into my current children. That is, for a root, suppose f of root is called. What will happen? If root equals to null, do nothing, simply return. Otherwise, if root is not equals to null, what will happen? You will first change the root data to 0. Root data equals to 0. Now what will happen? If my root left is not null, then what will happen? You will say root data plus equals to root left plus equals to root left data, right? Adding the first value which was initially there. Then call the function for f of root left, and after it returns again the same line, that is root data plus equals to root left data. Now let me add the comments. This was for initial values of children, value of children, and this one was for grandchildren's, right? Okay, and I will do the same loop for if root right is not null. If root right is not null. Why I'm adding if statement? Because otherwise this will give me the segmentation fault. These two statements will give me the segmentation fault. If they are null, then it will give me segmentation fault. That how are you trying to access the null values data pointer, right? It doesn't have a data pointer. I will add the same 3 lines, just change root left with right, and I will get my answer and simply return the root, right? Because we have changed the values in place. Now what is the time complexity? As usual, the time complexity is same as the same time complexity of post or traversal, which is equals to O of n, where n is the number of nodes, and the recursion stack space as usual, right? So now it is time for us to see the code for it, which is actually very short. Alright, so you can see the coding section in front of your eyes, but before starting with the code, it's my sincere request, if you're new here, if you're finding this video helpful, please subscribe to my channel because it really motivates me, and do give the like to the video you are watching, right? Okay, moving on. First of all, change your data. So node, okay, if my node equals to null, this was the first case, right? Return. I cannot do anything for you. Otherwise, node data will be first initialized with 0, because the root, the main root, the true root of the whole subtree given to us as input doesn't have actually significance, right? Now what will happen? If node has a left, if node left is not null, then what will happen? First increment the data. So node data plus equals to node left data. Then call the function for the left part, that is to sum tree for node left, and then change the value again, that is not change but increment, that is node left data. As discussed, the first incrementation is for the current children and the second incrementation is for the grandchildren's data, right? Now it is time for us to copy it and go for the right part also. So I will just change each left to right and my work is done for the code. It is as simple as that. Binary trees are actually very simple. If you understand the concept, they're actually very simple to implement, right? Okay, and then simply return. Let us try to compile and run it. Hope it should work fine. Should not give any error, I guess. I don't think I made any. Okay, it is running fine. Let us try to do it on the submit test cases as well. Please one for. Okay, it is running fine, and hope you liked it. So please do consider subscribing to my channel, and please watch this playlist from beginning till the very end if you want to master the binary tree series. Thank you. Have a nice day.